Hello everyone, this video will provide an overview of variables in science, discuss how independent and dependent variables are related, and show you how to interpret graphs of these relationships using a game called Charty. Variables are any factor in a scientific experiment, and we'll look at some examples in a minute, but let's jump into independent versus dependent variables. So in any scientific experiment, the independent variable is going to be the variable that gets changed by the experimenter. And the dependent variable is going to be the variable that changes in response to that change. So we can think of this as a simple cause and effect relationship in many cases. So let's make up a pretend example here. Let's say I wanted to do an experiment to see how many donuts I could feed people. And maybe I give some people no donuts, I give somebody 1 donut every day, I give somebody 5 donuts every day, I have somebody eat 10 donuts every day, 20 donuts every day, whatever it is. So I had to set up a simple experiment to see what happens when people eat donuts. Well, the independent variable in this situation is going to be the number of donuts that that person is going to be eating. What we might measure in response to that independent variable is perhaps how much weight those individuals are gaining. That would be our dependent variable. We would expect that the people that are eating more donuts might be gaining more weight. So I, as the experimenter, could change how many donuts each person in the study gets, and then I would measure their weight to see how they were responding to those changes that I was making. So our dependent variable would potentially be how much weight people are gaining. We can also refer to these variables as the manipulated variable as the independent variable, and then the measured variable as the dependent variable, because most likely the thing that we are studying is something we're going to be measuring. For example, our weight in this case. So I am manipulating the number of donuts that each individual in the study is going to eat, and I'm going to then measure the amount of weight that those individuals are gaining. So again, the independent variable is the variable that the experimenter is changing, and the dependent variable is what is changing in response to that change. So we can say it depends on the independent variable. All right, so here is a simple XY graph. You've seen these before, and I've labeled the point 0, 0. It's called the origin, if you don't remember that from math. We have the x-axis running horizontal and the y-axis running vertical. The independent variable is always going to be graphed on the x-axis, and the dependent variable is always going to be graphed on the y-axis. If time is ever one of your variables, for the most part, it's going to be on the x-axis, and we'll talk about that a little bit later. But whenever we have an independent variable and dependent variable relationship, we're always going to put the independent variable, or the one that the experimenter is changing, on the x-axis, and the dependent variable on the y-axis. And as we move from the origin toward the right, the independent variable is increasing. And as we move from the origin upward, the y-axis, or the dependent variable, is increasing. And you'll see that here in a couple examples. So here's our first example. This is a simple graph showing some car wash fundraiser profits. So we're having a car wash, and the number of cars washed is on our x-axis. That's our independent variable. Maybe we've set a goal for ourselves to wash a certain number of cars. The y-axis then is going to show the dependent variable, or in this case, the profit. So the amount of money that we make, the profit, is going to depend on the number of cars that we wash. So if I wash just 1 car in this situation, I'm going to make $7. If I wash 2 cars, I'm going to make $14, so on and so forth. So as the number of cars washed increases, the amount of money we make also increases. And you can see, again, very simple XY relationship. Here's another example. This one is showing a study done by a biologist that has taken some kind of plant down to different depths of water, and they're studying how many bubbles it produces each minute. So they're probably doing some kind of study about photosynthesis versus depth here. And as you can see along our x-axis at the bottom there, That is our depth. That is our independent variable. So the experimenter is choosing different depths at which to hold this plant. And then we're going to measure the number of bubbles that it produces per minute. And that's our dependent variable. So that's on our y-axis. So you can see as we start here between 0 and 5 meters of depth, 0 being right at the level of the water, we're going to take this plant down in the water between 0 and 5. And you can see it's producing somewhere between 25 and 30 bubbles per minute. As we start to go down in depth to 5 meters and to 10 meters, the amount of bubbles increases. But as we start taking the plant deeper and deeper and deeper, the amount of bubbles goes down, down, down. So we can see that as our depth changes, the number of bubbles changes in response to that. So again, independent variable on the x-axis at the bottom is depth. The dependent variable, the bubbles per minute, is on the y-axis. And the bubbles per minute depends on the depth at which the plant is held. All right, here's another simple one. This one is hot dogs sold per day. Monday, Tuesday, Wednesday, Thursday, Friday, take the hot dog card out, and we sell 10, 30, 30, 50, and 70 hot dogs. So you can see that the number of hot dogs sold depends on the day of the week that I take my card out. So in this situation, the day is the independent variable, and the number of hot dogs is the dependent variable. And here's a really big tip for you. Generally speaking, if time is one of your variables, in this case days, it's almost always going to be the independent variable. There are other circumstances where that might not be true, but in general, if time, so seconds or minutes or days or months or years, if that is one of your variables, it's almost always going to be your independent variable, and you'll graph it on your x-axis. All right, so we are going to look at some more graphs using a game called Charty Party. Charty Party is a game very similar to Apples to Apples. The game is going to give us a card with an independent variable already graphed on it, and we get to choose our favorite dependent variable for that graph. So let's head to Google Classroom, and here is Charty Party 1.0. All right, we'll be playing around with some more of these, but here's our first one. And this is a graph of Instagram followers. And you can see that this card has provided us with an independent variable of Instagram followers, but it's missing its dependent variable. That's where you come in. You get to choose, much like Apples to Apples, your favorite card below. And you're going to match it up based on whether you think it's funniest or most serious or whatever your criteria for choosing a card might be. But let's take a look at this graph real quick. They've already got the orange line on here, and it shows when we have 0 Instagram followers, whatever our dependent variable is that we choose is going to be low. But as we get to 1,000, 10,000, 100,000, and 1,000,000 Instagram followers, whatever it is we choose slowly starts to increase and then kind of rapidly increase as we get to 1,000,000. So keep that in mind as we look at our choices of dependent variables. So we're going to scroll down and take a look at these. If they're too small on your screen, you can push Control and plus sign, and that'll help you zoom in so you can see them a little bit better. All right, here's our first one. So this is how disappointed your ancestors would be if they could see you now. So as we have 0 Instagram followers, this value on the dependent variable is pretty low. So 0 followers, our ancestors wouldn't be that disappointed in us. But as we gain more and more and more Instagram followers, our ancestors become more and more and more disappointed in us. So that's your first choice. Choice number 2 is the number of ants you'll allow to crawl on your body before doing something about it. So again, as we have no Instagram followers, we have very low tolerance for allowing ants to crawl on us. But as we get more Instagram followers, we'll allow more and more and more ants to crawl on us before we do something about it. Maybe we're doing it for likes or views or whatever. All right, third choice, the number of toppings you put on your sandwich at Subway. So again, very few Instagram followers, we only put a few toppings on our sandwich, but The more followers that we gain, the more toppings we feel like putting on our sandwich. And finally, our last choice here is the size of unnoticed booger on your face. So if we have no followers, we can only tolerate a very small booger on our face. But as we get more and more and more and more followers, the size of booger that we're okay to not notice gets bigger and bigger and bigger. So those are your 4 choices. You can head over to Google Classroom, find this assignment, and vote on your favorite dependent variable, which is the orange cards, that matches up to our independent variable. So in this study, basically what we're doing is we're finding people that have 0, 1,000, 10,000, 100,000, and 1 million Instagram followers, and we're seeing what response they have to various dependent variables. So you get to choose. All right. So that's going to wrap up our discussion of variables. If you have any questions about variables, still need some help understanding the difference between independent and dependent variables, or you're not quite sure about this Charty Party game, please let me know. Otherwise, we're going to kind of continue doing some of these Charty Parties just to get used to talking about variables and seeing how some graphs can change as you look at them. We'll talk to you later.